A confirmation about the audio, please, guys. If the audio is available and is clear, kindly confirm. Thank you. So, we had initiated the discussion about the tricellular model of atmospheric circulation, and we had taken a look at why it is referred to as the tricellular model. Okay, so we had taken a look at the fact that how this circulation happens and what are the various factors which initiate this kind of a circulation overall. Now, in that we had noticed that around the region of equator, that is around 0 degree roughly, you have the creation of a thermal low pressure. Okay, so basically here we observed that you had a creation of a thermal low pressure. So this thermal low pressure, that is what is also referred to as equatorial low. Okay, now here you have the creation of a dynamic high pressure around 30 degrees. So this is what is also referred to as the subtropical, that is immediately beyond the tropics, subtropical highs, high pressure. Then you have the other dynamic low pressure which is created due to convergence of winds, and that is subpolar low pressure. And eventually you have the creation of high pressure at 90 degrees, and that is what is polar high. Okay, so this is the tricellular model we had seen. This is what is referred to as the Hadley cell. Hadley cell. This is what is referred to as the polar cell. Now, Hadley and polar cells, they are initiated or they are driven by the thermal pressure zones which are created at pole and equator. In between, the air circulation initiates another cell in between, and that is what is referred to as the Ferrel cell. Okay, Ferrel cell overall can be deemed to be thought as the entirety of the circulation of the Ferrel cell is driven due to dynamic movement, and Ferrel cell creates dynamic pressure zones at both the ends. Okay, now from here, let us initiate the discussion and let us delve deeper into the concepts. I hope that we are comfortable up till now here. Now, this particular aspect of equatorial low, in this region, you have, if you will observe, here also there is a convergence of wind which is taking place. Wind is converging from both ends, even in this area. Now, as there is convergence of wind which is happening, so winds are coming from where? From the tropical areas of the planet. We can say that in this region, around 0 degree, the winds are coming from the tropical areas of the planet, isn't it? So that is why this is a zone which is also referred to as intertropical convergence zone. Intertropical convergence zone. Okay, because here you have winds from both the tropics which end up converging there because of the low pressure created at the region of equator. Now here you will observe two overall, just a recap of it, two thermal pressure belts, pressure zones. What are those? You have the ITCZ or the equatorial low and polar high. And then two dynamic pressure zones. Which are those two dynamic pressure zones? There you have subpolar high or subpolar low and subtropical high. Now here, to think about it, if you apply your logic here, basically, when we talk about the ITCZ, ITCZ is a thermal low pressure. It is created due to immense amount of heating. Now, if I take you to the world map for a brief moment, if I take you to the world map and if I mark the region of equator, now during the months, let's say June, July, or May, June and July, May, June and July. Here, think about it carefully. If I ask you, where is it that the temperature will be higher? Will the temperature be higher over India in A, or will the temperature be higher over the water body in B? We have discussed about the differential rate of heating of land and water. So where is it that the temperature will be higher, A or B, during these months? Obviously A, isn't it? So A will always experience higher temperature. Now again, if I ask you, where is it that the temperature will be higher during these months? Over the Sahara Desert, let's say C, or over the forested area in Africa, that is D? Where do you think the temperature will be higher, C or D? What do you think? It will be C, right? Because that is where immense amount of heating in the desertified regions will occur during the summer months. So that basically tells us that low pressure driven by temperature will be created in this entire zone. ITCZ always indicates a region of absolute low pressure. So that ITCZ, it means that the ITCZ is prone to shifting in between the various different seasons. During the summer in the southern hemisphere, ITCZ can end up shifting to the south. During the winters, during the summer season in the northern hemisphere, ITCZ can shift to the north. So the ITCZ is prone to shift because of different amount of heating. Now suppose the ITCZ shifts somewhere here during the months of May, June, July, or let's assume even here. So the air will start rising from here itself. Okay, air will rise from here and it will diverge. It will cool down at a later stage. It might actually fall here, isn't it? So the high pressure which is earlier created at 30 degrees, that high pressure might shift to 35, 40 degrees. Similarly, when we talk about the southern hemisphere, when it is summer in southern hemisphere, during that time the ITCZ might very well shift here. So the winds will be rising from here and the winds might end up falling somewhere here itself. So basically what you have to understand is that all these pressure belts, they shift in between the various seasons. So we can say, if I consider this, pressure belts shift between seasons. Now, when it is summer in northern hemisphere, pressure belts shift to the north. Shift to the north. All the pressure belts will slightly shift to the north. All of them will shift slightly to the north, right? When it is summer in the southern hemisphere, pressure belts shift to the south. We can say this, that pressure belts, they are not static, because it is driven by the position of the equatorial low or the ITCZ. If the ITCZ shifts ever so slightly, if the ITCZ from here shifts ever so slightly in the northern hemisphere, all the respective pressure belts will also experience a shift slightly so. Now, these pressure belts, they also are able to drive winds on the surface. Now here on the surface, if you will observe the movement of the winds, you will observe that from 30 degrees on the surface, the wind is moving to 0 degrees. From 30 degrees, wind is also moving to 60 degrees. And from 90 degrees, wind is also moving to 60 degrees. But here, when you take a look at the movement, you also have to consider that this movement will account for the Coriolis force and the bending due to Coriolis force as well. So let's suppose you consider the planet. Let's suppose you consider the region of equator. Let's assume that ITCZ is lying at equator. Let's assume this is 30 degrees. Okay. Let's assume this is 60 degrees. And this is 90 degree. This is 30 degrees south. This is 60 degrees south. And this is 90 degrees south. Now, on the surface, winds are moving from 30 degrees to the region of equator in the northern hemisphere and 30 degrees to equator in the southern hemisphere. So ideally, the winds are moving from 30 degree to 0 degree, but they will be bending to the right in the northern hemisphere because of Coriolis force. So the winds will move like this. The winds will be moving like this. In the southern hemisphere, they will be bending to the left. So again, in the southern hemisphere from 30 degree to 0 degree, but they will be bending to the left. So that is where this is basically the movement in the southern hemisphere. Okay. Then furthermore, winds originate from 30 degrees and they move towards 60 degree. Here you will see on the surface, the winds are moving from 30 degree to 60 degrees all the way. So the winds will originate at 30 degrees and they will be moving towards 60 degrees in both the hemispheres, but they will be observing a deviation due to Coriolis force. So here they will be bending to the right. So here you will have this kind of wind movement. In the southern hemisphere, they will be bending to the left. Then after that, from 90 degrees to 60 degrees also wind will move in both the hemispheres. Here they will be bending to the right. And here they will be bending to the left. Okay. So these wind systems that you see moving across the planet, now these wind systems are going to be prevalent throughout the year because the pressure belts, they might shift. They might become irregular, but they are in existence throughout the year. That is why these winds are what are referred to as permanent wind systems, and they are referred to as permanent winds in general. Now, the winds are generally named based on the direction from where they originate. If the wind is coming from east to west, they will be referred to as easterlies. If the wind is coming from west to east, westerlies. So generally the direction in which from which the wind is originating, that is the name associated with the wind. So here, accordingly, here you will observe these are what are referred to as, these are moving from east to west direction. So here you will observe these are polar easterlies. Polar easterlies. Here also you will have polar easterlies. Then from 30 to 60, they are moving in general from west to east. So that is why they are referred to as westerlies. Westerlies in the northern hemisphere. Here also they are coming from west to east. So here also they will be referred to as westerlies. Now here, in this region between 30 degree to 0 degree, you will observe that they are actually moving from northeastern side to the southwest in the northern hemisphere and southeastern to northwest in the southern hemisphere. So these are referred to as northeasterlies or southeasterlies, depending upon the hemisphere. But in general, these winds are what are also referred to as trade winds. Trade winds. Why are they referred to as trade winds? Because historically, these were the winds which were used by the sailors in order to navigate from one region to another. Hence the name trade winds has stuck on, and hence the name trade winds has been used for this delineation. So that is these three wind systems overall that you see. These three wind systems are the permanent winds driven from the pressure belts. So from the various pressure belts, you have these wind systems which are driven. Now, these pressure belts, basically they shift slightly north and slightly south. All these pressure belts, they will be moving slightly north and slightly south. So these wind systems also, they will be shifting slightly north and south in between the various different seasons. Now these pressure belts also, they are known by different names. For example, in the region around 30 degree, here, the subtropical high pressure belt, this is also what is referred to as the horse latitudes. Horse latitudes. That is the subtropical high pressure belt. That is what is the subtropical high pressure belt. Okay. Now here, ideally why it is referred to as horse latitude, there is an anecdotal story behind it. Most of you would be aware of this. So it is referred to as horse latitude because in a region where there is a high pressure, where you have sinking air, so here the winds will approach the ground and then they will diverge. Okay, they will diverge. If you are standing here, you will experience the wind blowing across your face. If you are standing here, you will experience the winds blowing across your face. But if you are standing or if you are situated in this region, will you experience any wind movement at all? You will not experience any wind movement because the wind is sinking above you and is diverging, and it is not sinking at a point Just because we are able to draw it as a point on the map or on the image doesn't mean it is sinking on a point. Each degree is a significantly large distance. So for a considerable distance, you will not observe any movement and no cloud formation. High pressure generally means lack of rainfall, because for formation of clouds, you need rising air. Rising air will cool down, condense, and lead to formation of clouds. So in this region, you have no rain and no wind. So earlier what used to happen was that as the merchants would travel, as the sailors would travel through this region, they would come across these latitudes of high pressure where the ships would not move at all because there would be no wind in that region. And it would be very oppressive because no rainfall as well. So, and earlier when the sailors and the merchants and the traders would travel, they would carry a lot of horses along with them in the ships as well, because once they come to the land, they would require those horses to further travel. Many of the times for trade also, they would carry the horses. So in these areas, what they would do is they would basically push the horses into the water, right? And they would basically throw the horses in the water in order to conserve the resources, and at the same time, in order to create some kind of ripple in the water which could push the ship ever so slightly forward. Maybe the wind would pick it up later. With that hope, they would push the horses in the water. And that is why these high pressure areas, they would be referred to as the horse latitudes. So that is why the subtropical high pressure belt, that is referred to as horse latitudes. Then this ITCZ, this is what is referred to as doldrums. Now, why doldrums? Here again, you would not experience any amount of wind movement, but you would experience rainfall. So why is it that you won't experience wind movement here? So observe, if let's say this is the region of the ITCZ, the winds are coming, they are getting warmer, and they are rising up. So if you are standing here, you would experience the wind movement. If you are an individual standing here, you would experience the wind movement. But if you are an individual standing here, will there be a wind movement? No. But then here, basically, you will observe what? Cloud formation. Because rising air eventually would bring some amount of rain as a relief. So in the region immediately along the ITCZ belt where it is, so in that region around the ITCZ, in that entire area, because please understand the pressure belt and the pressure zones, that again I will reiterate, when we say a pressure zone or a pressure belt, it is not a latitudinal pinpointed position, it is a zone. It can basically be present for 10, 20, 50, 100 kilometers width. That can be the pressure zone. So here again, very calm conditions, and no wind movement. So that is how few of these pressure belts, they are named. Okay, this is basically the idealistic aspect, that how the ideally when you are drawing it by logic, that is how it is supposed to behave. But as we have already talked about it, that in real practical world, rarely will you come across any situation which is idealistic. So if you have to look at it, that where this high pressure and low pressure is experienced across the globe, now take a look at the map here. So take a look at the map in the month of January. In the month of January, it is winter in the northern hemisphere, summer in the southern hemisphere, right? So when you have summer in the southern hemisphere, pressure belts generally shift slightly to the south. Observe, you don't have a continuous pressure belt, rather you have a pressure zone. pockets of pressure which are created. Observe these and let me know it is a part of which pressure zone. So here observe the low pressure around equator. These low pressures around equator. This low pressure has come over here. Which pressure zone are we talking about when we are indicating this low pressure? Let me know. Which pressure zone are we talking about? Good. It is the ITCZ or the equatorial low. Very good. Now, right next to the equatorial low, you have the subtropical high or the horse latitude. Observe the high pressures. So rather than a continuous belt as observed in this image, you will observe that you have cells of circulation. So here the air will rise up from this particular portion. Maybe it will sink somewhere here. Maybe it will sink somewhere further ahead. Maybe it will sink here. So that is basically the creation of the pressure zones which are present. This is the latest model of air circulation, which talks about pressure zones rather than pressure belts. Obviously, for your general studies, this image is not required. For your general studies, if this much is required, if you know this much, more than sufficient. This is just to indicate to you that what happens in reality. So this high pressure you will also observe to be formed in the southern hemisphere. And here again, notice one thing. In the southern hemisphere, the isobars, look how in a parallel manner almost they are placed. Indicating what? Indicating that in the southern hemisphere, there is a very uniform change of pressure because of presence of water body around. Now, after that, look at the low pressure closer to the polar area. Look at the low pressure. Now, which low pressure is this? Which is the low pressure that we are talking about here? That is the subpolar low pressure. Okay, here also you will observe, but in the southern hemisphere, observe it is very uniquely in a kind of a straight line. Why? Because it is dominated by water. Okay, now in this situation, here, these low pressure and high pressure cells, these form around certain regions. For example, here around Aleutian Islands, you have the convergence and the rise. So Aleutian low, Icelandic low, Siberian high. This is what is Azores high, right? These are basically based upon those names of the region that you find here. So the Aleutian or the Aleutian low is significant low pressure which is formed here. Icelandic low is a subpolar low pressure formed around Iceland. Azores high is created around the eastern portion of Atlantic Ocean, and this is around the Azores Island which is present. Then in the month of July, if you observe here, observe in the month of July. Now in the month of July, it is summer in the northern hemisphere. All the pressure belts will shift slightly to the north. So observe first of all the low pressure. Observe the low pressure. Now this is which particular pressure belt are we talking about here? We are talking about the ITCZ. Okay. Then observe here that because the ITCZ has shifted, earlier you had the situation of a Siberian high in the month of January. Here there is no Siberian high which is created because obviously the ITCZ had significantly shifted. The Azores high, that also shifts ever so slightly. Now, rather than the Aleutian low which was formed earlier here, now you have the subtropical high pressure belt in the form of Hawaiian high. In the southern hemisphere also, all the pressure belts, they shift slightly to the north because of shifting of ITCZ. So look at the subtropical high pressure zone, majorly across a straight line. Why? Dominated by water body, so uniform change in temperature. So this is how you carry out or you observe the creation or the formation of the pressure zones and the pressure movements initiated by the pressure zones, creating the presence of permanent wind system in general. Okay, is that understood, or is there any doubt in that? Bharti doldrum 5 degree or 0 degree, ITCZ doldrum. Okay, any doubts that any of you have? Now is the time to ask it. Okay. Need to remember the names of these highs? No. For general studies, you don't need to remember this. Ideally, if you know this, fair enough. That is always going to help you out. But if you don't know this, no harm done. This is just to show you what happens in real world. For general studies, as I told you, up till this slide, that is more than sufficient. Okay? Generally, in the books, in the reference books that you come across, in the books, you won't come across this aspect of the Azores high, Icelandic low, Aleutian low. Then you have the Hawaiian high, Siberian high. All these are not mentioned in the books in detail. That is why we have highlighted this. But otherwise, it is not required for general. If you know it, fair enough. Those of you who will study for optional, you need to know this. But those of you reading for general studies, more than sufficient. Doldrums have an impact, or doldrums basically understand that these are the calm conditions which prevail around the ITCZ. Why do calm conditions prevail? As I told you, ITCZ is a region of equatorial low. So if, let's say, you are standing here, you will experience wind moving towards ITCZ. If you are standing here, here again you will experience wind moving towards ITCZ. But if you are standing here, you will not experience any substantial wind movement. So due to calm conditions, that is why it is referred to as doldrums. Why ITCZ is shifting? Because the heating that will be provided, see, ITCZ is an absolute thermal low. So ITCZ will shift in that region wherever you have maximum temperature. That will be the absolute low pressure. So that is why ITCZ is also referred to as the equatorial low pressure, or it is also referred to as the convergence zone, because the absolute thermal low pressure is created. So when you talk about, let's say, the month of June, July, Indian landmass will be much hotter as compared to the Indian Ocean. So the low pressure will shift there. As the ITCZ shifts, all the other pressure belts shift accordingly. It helps in writing mains answer names of pressure zones. Yes. Ideally, if you indicate the names of these, for example, if you are writing about the tricellular model, and if you are writing about, see, everybody, all the candidates who will appear in the mains examination, have that much trust in the candidates. Never overestimate yourself, even though that is the most common phenomena of all the candidates, that even if somebody is studying for 1 year, you don't know the pedigree that I have. Even if I will study for 5 days, I will make up for what others have did in 1 year. So have that kind of a presumption that everybody has studied more than you, if not as much as you have. Minimum they would have done is studied as much as you have. So the answers that they will write, all of them will be able to write about the doldrums, the horse latitude, the westerlies, the trade winds, all of them will be able to write. It is in these portions where, let's say, you are able to highlight that the subtropical high pressure belt, for example, the Azores high, the Hawaiian high. So if you are able to highlight these, obviously your answer will get a greater amount of merit. But if you are highlighting these, underline these as well. Okay. ITCZ required low thermal region? No. It requires high heating, very high heat, and an absolute low pressure. So a thermal low, so to say, not low thermal low is created there. Okay. Now we move ahead. I hope this is particularly clear. Now we move ahead to the portion of local winds. Now, when we talked about the permanent wind systems, why were they referred to as permanent winds? Or planetary winds also they are referred to. That is because the permanent or planetary winds overall, if you look at it, then these wind systems, they are prevalent throughout the year. Even though they shift, they change in terms of velocity and magnitude, but they are present throughout the year. When we talk about these winds, they are also to be found present across the planet, hence they are referred to as permanent or planetary winds. When we talk about local winds are regional. They come into existence for a brief duration and also in a particular region only. They are not to be found in different parts of the planet. So these are basically wind systems moving temporary winds in existence for a short duration and also existent over a small region only. Okay, they are existent over a small region only. So that is the characteristic of local winds. Now these local winds ideally are relevant only for your prelims. You don't get questions from the mains in the mains examination from these local winds. However, if it is framed, you should thank your lucky stars because it will be very easy to answer. So in prelims, you will get questions regarding local winds, names of local winds, their type, whether they are cold or warm, and then the region where they exist. So based on these topics, you get questions being framed in the prelims examination. Now, when we talk about these local winds, you have to understand that these local winds, they are of two types. One is daily occurrence, which are in existence on a day-to-day basis, where the movement during the day will be different as compared to the movement of the wind during the night. For example, you have land and sea breeze. For example, you have mountain and valley breeze and valley breeze. And then you have the seasonal and regional winds. For example, here, let's consider what we experience in India and what is the phenomena of India, northern part of India only, northern and central portion of India only, Lu. Then what we experience in United States or northern part of North America, northwestern part of North America, that is Chinook. What we experience in the region of Europe during winter, you have Mistral. What we experience in the region of Alps mountain, that is Fohn. What we experience moving across the region of the Sahara Desert, and across Sahara Desert you have two local winds. You have Sirocco and you have Harmattan. So these are regional winds which are in existence only in a certain region, not all across the planet. So here we shall be taking a look at few of the important of these local winds. We shall try to understand the region and the phenomena which helps them move. So starting with the daily winds, the winds which occur on a daily basis, that is land and sea breeze. Now here, always keep one thing in mind, that the wind is named based on the direction from which they end up originating. That is important for the naming of the wind. So here, when we talk about land and sea breeze, so across the coastal landscape, this is very different from onshore and offshore. Onshore and offshore winds, they occur across very large distance. When we talk about land and sea breeze, they occur over a very small distance overall. As you can see, only the distance is around 50 kilometers overall for the entire circulation. So why does this blow and what is the phenomena behind it? So let us consider daytime and nighttime. Now during daytime, if I ask you, which now I will frame a, let's see, because when I ask you the question, many of you choose to stay silent. So here, during day, which region is colder, cooler? A, land, B, water. Okay, so I'll give you 30 seconds. So whichever is colder, the other region will be warmer as well. Good. Still few of us have managed to give the incorrect answer, but majority of us have given the correct answer. During daytime, water is colder. Now, encouraged by this, I will frame another question. During night, which region is colder or cooler during the night time? So Bharti, I guess you have understood the portion of Azores High, or is there a doubt which prevails? Kindly let me know. Good. So here, more number of people have given the correct answer in this. So during night, land is colder. During day, the water body is colder. Or if I flip it out, if I totally revert it up, during daytime, the land gets much hotter. Here, this land will get very hot. Comparatively, water will be cooler. So in that local region, you will have the creation of a high pressure here, and simultaneously you will have the creation of a low pressure, thermal low pressure here in that small area itself. Low pressure means air will start rising up. There will be winds coming from high to low. Winds always blow from a high to a low. So the winds will be moving. from the water body where you have a comparative high pressure to the land area, they will be rising and creating the cloud cover, and they will bring rain. That is why during daytime, if ever you remember or try to recall that when you were standing or whenever you have stood on a sea coast, you would have observed that during daytime, the wind is moving towards your face from the sea. That is what provides a kind of a relief overall. Now, this wind is originating over the sea and moving over to the land. That is why this is what is also referred to as sea breeze. This is what is also referred to as the sea breeze. And during night time, the concept simply flips over. Because during night time, comparatively water is warmer. So here you have a comparative low pressure, whereas the land is colder, where you have a comparative high pressure. So the winds will be moving from land to water, and that is what will lead to the formation of land breeze. Okay, so that is why sea breeze is experienced during day, during afternoons in general, and land breeze is experienced during night. Now, what it does is it helps moderate the temperature in the coastal area. This is not the onshore and offshore wind. Again, I will reiterate, it is not your ideal onshore and offshore wind. So during day and during night, the frequent circulations which happen in the coastal area, they ensure a kind of moderation of temperature. They don't allow the temperature to go to the extremity. The other implication of this is, let's suppose when you talk about a coastal area, let's say Mumbai, coastal areas such as Chennai, coastal areas such as Kolkata. Now, if let's say there is a lot of pollution which is happening, but will those pollutants stay in the air for a longer period of time? No, because the pollutants will be driven away by these winds. So that is why, regardless of the source of pollution, you will find that Mumbai, Kolkata, Chennai, they will be comparatively cleaner in appearance. Whereas in the case of Delhi, you don't find such a situation of land and sea breeze. That is why you will find that in Delhi, the pollution or the pollutant stays in the atmosphere for a much longer duration, right? So this also allows for mixing of the air, to create moderate conditions. Moderate conditions overall. That is what is observed in the case of land and sea breeze. Okay? Now, something very similar happens across the mountainous and the valley areas as well. Now, during the daytime, when you talk about the mountainous regions, during the daytime, and here we are not talking about tall mountains like Mount Everest, etc., generally the hilly areas that we consider. So during daytime, due to higher insolation, higher level of insolation which is experienced, you will observe the creation of a low pressure zone at the top. You will observe the creation of low pressure here. Low pressure will be here because of higher level of insolation. Whereas near the valley bottom, comparatively, you will come across what? Near the valley bottom, you will come across a comparative high pressure of sorts, right? So the wind will be moving from valley up to the mountain. That is the wind movement that you will come across during the daytime. Okay, so during day, when you consider during daytime, mountain top will have the low pressure. So the winds will be moving from the region of the valley up till the mountain top. So that is what creates during the daytime What kind of breeze? Will it be mountain breeze or valley breeze? The winds are named after the region where they originate. So will it be referred to as mountain breeze or valley breeze? Very good. It will be referred to as valley breeze. Whereas during the night time, here, observe that the mountain top will be losing heat at a particularly faster rate. They will lose heat very quickly in general. Why? Because here you will find that the air above it is not very thick. So they will be losing heat at a particularly quicker pace. So there you will have cold conditions and development of high pressure. In this region, you have development of high pressure. Whereas the valley bottom comparatively will be warmer. So you will have development of low pressure here. Low pressure. So the winds will move from mountain to the valley. So during night, this is what is mountain breeze. Mountain breeze. Now, what is the impact it will have on climate? During daytime, the wind is moving up the mountain. Eventually, it will be forced to rise up. As it is rising up, it will expand ever so slightly. And when it expands, it cools down. It cools down means the water vapor will condense, means there will be cloud formation, means there will be rainfall or precipitation. And during nighttime, what do you think will be the weather condition which will happen? If the valley, let's say, is narrow and the valley is constricted, during nighttime, what kind of weather conditions can you experience in this particular region, particularly in the valley? Cold conditions, okay. What is the weather phenomena be? What will be the weather phenomena referred to as? No, during nighttime, rain won't be observed. Very good. Here, you will experience valley inversion. Valley inversion will be observed at the valley bottom due to these mountain breeze which move during the night time. Okay, so these are your daily winds which are in motion. Now we take a look at the seasonal winds. Now, seasonal winds, we start with the wind system which moves over India, especially the northern part and the central part of India only. Southern part of India does not experience this. To the south of Tropic of Cancer, you don't experience this phenomena, and that is the phenomena of Lu. Now, basically, these are hot and dry winds which blow very strongly over the northern plains of India and Pakistan in the months of May and June. Now, their direction is generally from west to east, and as they cross the region of Thar Desert and so on, they become hot and very dry. And they bring about a significant amount of heat, and that is why in the region, the temperature shoots up. So the temperature shoots up around 45 to 50 degrees Celsius when they move in the afternoons. Around 3 p.m., 2 p.m., around that period of time, you will experience this Lu. So remember, if you have lived in these areas, if you recall, the children are never allowed to go out, and the aspect is that you will get exposed to Lu, because that sudden exposure to the warm conditions, that can cause a heat stroke and associated problems there. But that is what parents and all your elders will use this as a mechanism, or would have used this as a mechanism to stop you from going out, that you will get struck with Lu, and that is the end of the world then. So this is the phenomena of Lu. It is in existence only over the region of India and Pakistan. Okay. Now, valley breeze, Sundaresh, is basically, understand, valley breeze is observed during daytime, when you have the creation of low pressure on top of the mountain because of high solar insolation. So that low pressure comparatively valley will have a comparative high pressure. So the winds will be generated from valley to the mountain top. Okay. Now, when we talk about loo, why is it that the loos are in circulation, or why do the loo comes in circulation? So there is a logic behind it. You don't need to understand that. Nobody will ask you the reason about it. But if you are interested enough, I will always tell you the reason. So this is, let's suppose, the Indian subcontinent. Okay. Now, here you have the region of Balochistan, Thar Desert in Pakistan, and Thar Desert in Rajasthan, India as well. So here, during the months of late April, not generally late April, but May and first part of June, during that period of time, there is a low pressure created here also. There is a low pressure created here also. Now, this low pressure will attract winds from all directions. Wherever you have low pressure, winds will be attracted. Now, winds, when they reach here, let's suppose the winds they reach here in this region, in this area. Now, this particular area of Balochistan and Sindh region in Pakistan, now they have got surplus of air particles because the winds have reached there. Now, those winds find out, or those particles find out, that across the northern belt and the central belt of India, there's significant amount of heating and there's a very active low pressure. So that is when these surplus winds will initiate a motion. And the first region that they will cross is the Thar Desert of Rajasthan. Now, when the winds are crossing over Thar Desert, they will obviously gain the property of the Thar Desert. They will become hot and they will become dry. And then after that, they will bring significant amount of dry weather conditions in these areas, and dry winds shall be moving over these particular areas. Okay. I hope this is understood. Utkarsh and Bharti. Right? Westerlies is the main reason for low in north? No. Westerlies, by this point of time, in the month of May and June, the westerlies, they shift further north because of shifting of the pressure belts. Okay. Benita, which portion is it that you need to understand? Okay, fair enough. I will explain the entire portion again. So, during the months of May, June, here, during the months of May and June, you have significant amount of heating. The temperature soar to a region of 45, 47, 48 degrees Celsius, 50 degrees Celsius even. And that is not only in India, even in the neighboring region of Pakistan, you have very high temperatures. Balochistan is one of those rocky places, those hilly regions which also experiences a lot of heating. And the Sindh province in Pakistan, the Thar Desert region in Pakistan, that will also get heated. So here, you have, first of all, the creation of a low pressure in this region. Significant low pressure. Now, this low pressure gets the movement of the winds from all area. You have accumulation of winds from all area happening around this low pressure. Subsequently and simultaneously, you will observe that the northern plains here, they will also be very, very heated up. The Gangetic plains, the central part of India, they will also be very heated up. Now, in this region, something else happens. So here, first of all, the winds will come here. They will start accumulating over the region of Karachi and Balochistan, the Quetta region of Balochistan and Karachi. The winds will start accumulating here. Now, once the winds accumulate here, this low pressure, it will not become an immediate high pressure. This will get converted into a comparative high pressure gets converted into a comparative high pressure. After all, there is no rule that winds will blow only if the pressure is beyond this. Wherever there is a difference of pressure, winds will move, right? Winds will blow from a high to low. So here you have a comparative high pressure. In that entire belt, you have a significantly, very significant and exponential low pressure. So the winds from here will be attracted and will be moving over the region of central and northern parts of India. Now, immediately they will be crossing the Thar Desert. That is when they will get very dry. They will become more hotter as well. And then they will be reaching that low pressure. So in a way, they are moving towards the low pressure, but these are very warm and very dry winds. Okay? Is that understood now? Okay. Does Pakistan also have the Thar Desert? Yes, absolutely. Thar Desert, for a significant portion, extends in Pakistan also. What did you think, that the Thar Desert ends with the boundary of India or what? It extends. See, deserts and all these, they don't know international boundaries. Why not the winds move from south towards the north? Is there any reason? Because south does not, see, in the southern peninsular portion of the country, you have to understand that by this time the ITCZ is also moving. So in these months generally, in southern part of India, you have a different circulation at the local scale, which is already initiated. So here, that is what will bring sufficient amount of rainfall in certain areas. Other than that, these areas in the southern portion, they will also develop a comparatively low intensive low pressure, but here the winds will move from this. Generally, the eastern portion of Maharashtra, the region of Telangana, the northern portion of Karnataka, the portion of Andhra Pradesh and Tamil Nadu during these months, they will develop the low pressure. And the coastal Karnataka, the Kanara coastline that you have, Dakshin Kannada, Uttar Kannada districts, Udupi, and then the Malabar coastline across Kerala, along the region from Ratnagiri in Maharashtra all the way moving towards Goa. These will develop a comparative high pressure due to the winds coming from the Arabian Sea, causing some relief rainfall. So that is where in southern India, you will have the wind movement engaged only in this portion. Okay? Good. Now, but anyways, nobody is going to ask you about the reasons of Lu, why the Lu is in circulation. But now that you know it, I hope that in the coming days, when you read the newspaper headlines now, I hope that it makes sense. And I hope you are able to differentiate yourself from the rest of the candidates who simply read the newspaper headlines that, okay, Indian Meteorological Department has issued a warning. Something might be happening. There is warm wind, high temperature. Who cares? I have to do other things, etc., etc. So I hope now you will be able to have an informed level of understanding for these nuanced concepts. Now we come across another local wind, and this is a regional wind which is observed in the northwestern part of North America. If I show you the exact region, if I can show you the entire exact region here, let's suppose here. In this particular area, you have the Rocky Mountains. In this particular region, you have the presence of Rocky Mountains. So here, you have the winds which move. Now, the winds will climb up the western side of the Rockies and they will get down on the eastern side. Isn't it? Now, this portion where they get down on the eastern side, that wind is referred to as Chinook. That wind is referred to as Chinook. So when we talk about Chinook, Chinook is a local wind which moves across the eastern slopes of the Rocky Mountains. Eastern slope of the Rocky Mountains. Now, they are also referred to as the snow eaters in that region, because these winds, they melt the snow in that area, right? The snow that is found across the Rocky Mountains in these higher latitudes, they start melting with the movement of Chinook. Why? Understand the logic here. So suppose this is the Rocky Mountain, okay? Now here, as the wind approaches this, the wind is forced to rise up. As the wind rises up, it will expand ever so slightly because it is moving into an area where the air density is very less. So it will expand ever so slightly. When it tends to expand, it will also cool down in the process, isn't it? So it cools down, it rises up, will lead to the formation of cloud here, will cause very heavy rainfall in this area. This region will be experiencing very heavy onset of rainfall. Now the wind which is left over, this wind, we can consider this wind to be dry, because whatever moisture was there, that has now been consumed to bring rainfall in this side. Now, this wind, after this, moves down. Now, as it moves down, can I say that it is moving into an area where the air density is generally high? We can say that. It is coming closer to the sea level, so coming to an area where the density is high, air density is high. So here, the wind will experience adiabatic compression. Adiabatic compression, which leads to heating. And that heating which is caused will raise the temperature. Already the wind was dry after coming from one slope. So now it is not only dry, it is warm as well. So the wind becomes warm. And then, even if the temperature is around 5 degrees, 6 degrees Celsius, it is enough to melt the snow in that region. So that is where it will melt the snow. The snow. Hence, it is referred to as snow eater. Okay, so this happens across the Rocky Mountains. Rockies. Now here you have to understand that any mountain will have two different slopes, right? Now the slope or the side which experiences the wind movement on its face, that is what is referred to as the windward side. This is what is referred to as the windward side. The side which is opposite to the windward side, which does not experience this wind coming to its face and basically does not experience rainfall as well, which is comparatively drier, this is what is referred to as the leeward side. So that is why you will find that Chinook is in existence in the leeward side of the Rockies. Okay? Now, a very similar phenomena also plays out in the region of the Alps mountain. Now, if I take you to the Alpine mountain ranges, I cannot take you to the Alpine mountain ranges. If I take you to the image of Alpine mountain ranges, so the Alps are present here. Right? So it will have a northern slope and a southern slope. Now the winds which are going to move in this region, here, these winds will rise up and they will move down. So the northern slope is going to be the leeward side of the Alps. So when we talk about the Alpine mountain range, the leeward side will be the northern slope. So there again, a similar phenomena is at play, where on the leeward side, on the windward side, while the winds will rise up, they will lead to the formation of clouds. They will bring copious amount of rainfall in the region. On the leeward side, these winds will be warm and dry. Okay? And in the northern slope of Alps, they will be moving. That is what is Föhn. Okay, it is not Fohen, it is not Fohen, it is Föhn. Okay, so the warm and dry wind like Chinook is called Föhn along the northern slope of the Alps mountain. These are more common during the months of spring and autumn in Switzerland, and because these warm winds come into play, they rid the area of any frozen ice or frost which is created. So the weather becomes quite pleasant in the valleys due to melting of snow. It is a different matter altogether that we people who live in the tropical regions of the world, we will find even these conditions to be very oppressively cold. But there it is referred to as a very pleasant weather. People go out cycling, and people, they actually go out on a lot of picnics during this particular time when the Föhn is in motion. Therefore, Valley of Switzerland is also referred to as the climatic oasis during the winter season. These warm winds, they allow for early sowing of various crops of wheat. They help in ripening of grapes, and otherwise the agricultural activities are also benefited. That is Föhn. Then you have Mistral. Now, both Föhn and Chinook, you will observe these are warm winds, warm and dry. When we talk about Mistral, it is a cold local wind. So this is generated during the winter season. Winter season in Europe. So during the winter season in Europe, obviously, if you compare the nearby regions, during the winter we have seen that the land gets much warmer and much hotter. So during the winter rather, if I correct myself, during the winter the land gets much colder in general. Water is comparatively warmer. So during the winter, the land becomes very cold. Very cold. Nearby water bodies, there will be a comparatively warmer water body during the winter. So you will have a nearby low pressure which is created. So here, the cold winds will be initiated from this region, and they will move through the countries of Spain, France, and so on, and their destination is the Mediterranean. So these winds, basically, they are more common and effective during the winter season because of development of high pressure over Europe and low pressure over the Mediterranean Sea. Why? Because the land is much colder during the winter as compared to the sea. Arrival of Mistral causes sudden drop in air temperature to below freezing point in general. The temperature drops significantly below freezing point. Then we have blizzard. Blizzards are very cold local winds observed in very high latitudes. That is in the northern portion of North America, northern portion of Europe and Asia, in the region around Siberia. That is where you have very strong and cold local winds coming from the polar areas which move into that region. So when we say blizzard, so basically you will observe these are violent, stormy, cold and powdery winds. If I take you back to the image here, let's suppose I take you back to the image. So during the movement of blizzards generally observed during the winter season, you have very cold winds because of extremely cold temperatures blowing over these areas and these regions. Okay. Now, in the meanwhile, as they blow, they will pick up the snow or snow along with them. That is why they give a kind of a powdery appearance. And there these winds will blow. Now here, you don't have any mountain system. from east to west, which can stop these winds. So here, these particular winds, they impact all the way even to the region of northern United States. They will bring about a sudden and sharp decrease in temperature. The temperature will fall quite significantly in this region. Okay, so suddenly you will observe a temperature drop which happens. So that is what is blizzard. So it is a violent, stormy, cold and powdery polar wind laden with dry snow and is prevalent in north and south polar areas. Visibility becomes very low because of the snow and the ice crystals, and sudden drop in air temperature to sub-freezing levels. Last year, you had a very sad event and a sad case where, and this happens almost every year in large proportions. It is last year where it was highlighted that I am not sure how many of you would have read the newspaper headlines, but you had an Indian family who was trying to illegally migrate from Canada to United States. I hope we are aware of the fact that the route from Canada to United States, it is very frequently used by the illegal immigrants. So first they migrate to Canada and there they cross the border from different areas, not through the main highways, but they walk through large distances. Now you had a family along with the kids who was traveling through from Canada and trying to enter into United States. It was then that they got stuck in blizzard. And that is when the temperature dropped so significantly that all of them, including the young kids who were present, all of them, they froze to death instantly. So that is where blizzards have a debilitating impact in the local region quite significantly. In the region around Canada, northern portion of Europe, etc., during these blizzards, many of the offices, many of the educational institutions, they have to forcefully shut it down because it becomes absolutely impossible to travel even on the roads because the visibility is reduced to almost 10 meters or 15 meters or even 5 meters sometimes because the wind carries a lot of that snow dust. So that reduces the visibility and the temperature is freezingly cold. Okay, so that is how you should catch up with these news stories as well. Mistral, basically, Hajra, Mistral is the cold local wind which moves across the western part of Europe, originates over the land areas in Europe, and then moves over to the Mediterranean Sea. Now, during the winter season, it is a land which gets very cold, and that is where the high pressure is developed, and that is where the Mistral moves. Santosh, Lu, Chinook, phone, it is only found in these places. Do we experience Chinook in India? No. Do we experience phone in India? No. We only experience Lu in India. So that is where these are regional winds, regional local winds which are experienced only in these regions. Then we have Sirocco. So when we talk about Sirocco, now this is a unique wind in terms of the impact that it brings over the region of Europe. Now Sirocco is a wind which originates over the region of northern part of Africa. Now, northern part of Africa has got the presence of red soil. So as the winds move over the northern part of Africa, here they pick up those red soil. Then they cross the region of Mediterranean. As they cross the region of Mediterranean, they pick up moisture along the way. And then they hit the southern part of Europe across the Italian peninsula. And then, because they are moisture laden from the region of Mediterranean, as they hit the southern part of Europe, they bring huge amount or humongous amount of rainfall. But along with this rainfall, the red sand particles that and the red soil particles that they had carried, that is also dropped. So the raindrops, they give an appearance of orangish red. And that is why a very unique phenomena, which is referred to as blood rain, that blood rain occurs or is observed in the southern part of Europe, especially across the Italian peninsula. So that is Sirocco. It is warm, dry and dusty local wind, blows in northerly direction from the Sahara Desert, and after crossing over the Mediterranean, reaches Italy, Spain, etc. Sirocco, while passing over the Mediterranean Sea, picks up moisture, yields rainfall in the southern part of Italy, where the arrival of rain is referred to as or is called as blood rain. Okay? Now, these are few of the local winds that you should be aware in the regions where they are moving. Okay, so here only for your prelims you should know this. This is something not asked in the examination in the mains in general. So here you will observe, look, this is where the Chinooks are, this is where the Phone is, this is where the Mistral is, then here is where you have the Sirocco, this is where the Lu is experienced. So like that you have Pampero in the portion of Argentina, you have Berg, Harmattan, Khamsin, all of this. So that is where you will get the details of this in your additional reading material as well. But ideally, you should restrict your reference to the portions or the regions where they impact and what is the impact that they create. Okay? Now, these are the list of the local winds overall. If you observe in the North American region, what are those local winds? This is for your pure exam purposes. Many of us, we regardless of whether we study or not and how much we study or not, many of us, our as a student, our general pastime is to collect materials, as much materials as is there in market. We like to collect it. So immediately when we come across any new material, immediately we get a printout of it, right? And even if we don't read it, that is kept somewhere. Even if the videos, we don't look at it, we download it, keep it in a folder so that one fine day when the stars will align, when the sun, the moon, all of them will start speaking to us, then we will study. So I come across many candidates. Believe me, 99.99% of the candidates come into this category who like accumulation of materials, who get a kind of a sound sleep. If they have taken a printout of 30 pages today, they will get a sound sleep. When they will study, that is a different matter. So this is another material for you. I hope that this is not restricted to the printout which is done. Here, if you will observe, you have these winds, local winds in the region of North America, along with the characteristic in South America as well, in Africa as well, okay, in Europe as well. Take a look at this. This should be looked at only from your prelims perspective. Only from your prelims perspective, take a look at particular aspect. And don't be that individual candidate who will simply take a printout of it, keep it somewhere in the drawer and in the study room. Okay? Why will you mug up, my dear friend? After all of this, even if you still start mugging up, that will be one of the worst things that you can do. Mugging up is done or should be done when you have no clue about what is happening, right? For example, let's say if you are mugging up the entire different types of theaters and puppetry actions which go on across the country, that is something where it is understandable that, okay, I have no clue why you have finger puppets, why you have arm puppets, iron puppets, so I'll mug it up. But even after studying all this, if you are forced to mug it up, that should not happen. Ideally, just try to understand it. After that, if you are not satisfied, you can mug it up. Okay, but first I would suggest you to try to understand. Okay. Now we come over to the portion of humidity and precipitation. Now it is here that we will come across the aspects of what do we understand by humidity, the different types of humidity, what is dew, what is condensation, why clouds are formed, how clouds are formed, why do we experience thunderstorms, why do we experience lightning, what are the different types of rainfall, What is that event or phenomena where people immediately start posting it on social media that look at what has happened to the world? Delhi is experiencing snowfall, Hyderabad is experiencing snowfall, and guess what? Today Bangalore also experienced snowfall. So what is that aspect? We will try to understand what is cloudburst, what is fog and mist. Everything we'll try to understand here. Now, this is a particular portion which is relevant significantly in your mains examination. You get direct questions from here. In your mains examination, you get questions in this portion from the area of cloudburst and hailstorms, thunder, storms. Okay. Sometimes you get about types of rainfall, but that is very rare nowadays. Types of rainfall. Now, in the prelims examination, types of clouds, hailstorm and cloudburst, types of rain, also types of fog. All these are the areas from where you get questions in the prelims as well as in the mains examination. That is something we will cover. Sometimes in prelims, you also get questions about basics of humidity. Basics of humidity. About what they are. Okay. So that is something that we will be covering in this particular module as we proceed. But before we move ahead with this module, we'll take a break, and we'll take a 10 minutes break. And after that, when we come, we will start with the portion of humidity and precipitation. Okay. And after that, we will be moving on into the portion of cyclones. So here, we'll take a break for 10 minutes. Channa Basava, additional reading material is very different from the annotations of the PPT. You have a doc file which is created where you have subjective portions and the definitions aspect, significantly newer areas, which are these are additional reading materials other than the class. What you should be aware of, that is included in the ARM. So kindly go through those ARMs. They are for your benefit only. Let's take a break and let's be back in 10 minutes. A confirmation about the audio, please. If the audio is clear and audible enough. Thank you. So again, before initiating the new module, let me ask the question. How many of us are comfortable till now? I understand that weekend sessions anyways are very long, tiring for you guys as well. So how many of us are able to understand and still have our mind open to the various concepts which are being taught? Okay. I hope it is not coming out to be a bouncer where it is simply flying over your head. Okay. So whenever you get a kind of very fatigued with this particular monotonous aspect of it, kindly let us know. Even though we are taking breaks in between, I hope that this makes it more tolerable for you guys. But understand, you have to develop the capacity to be able to concentrate for very long hours. Is it necessary to make diagram in the examination? Absolutely necessary. Absolutely. And will there be Coriolis force on the air circulation above the surface? Yes. Any object which is moving independent of the surface will experience Coriolis force. Even the oceanic circulation experiences Coriolis force. Even the airplanes, when they move from one region to another, they will experience Coriolis force. Okay, that is why if you observe a flight which moves, let's say, from Bombay to Delhi, you will observe that they take a movement slightly like this rather than straight away going for the displacement. So everybody or every independent moving object will take that kind of curved path. These diagrams need to be drawn with pencil, or pen is fine. Pen is fine. Because please understand, when you are writing the answer for the mains examination, right from the time of thinking about it, thinking about what to write, to the portion of finishing the answer along with the diagrams, you have around 8 to 9 minutes in your hand. So in those 8 to 9 minutes, obviously, you have to highlight the important areas as well. You have to make sense. You have to make the flow also. So pen will be more than sufficient. Okay. Why only geography class on weekend? Because this is the weekend batch, my dear friend. On the weekday batch, we have the sessions on the weekdays. So here we start, first of all, with the aspect of humidity. Now, humidity here, if we talk about it, what is it? It is basically referred to as the amount of moisture content in the air. Moisture is what? Water vapor, not liquid water droplet, water vapor. So the amount of moisture contained in an air, in any air parcel, in any unit volume of air, that is referred to as humidity. So amount of water vapor present in a parcel of air having a definite volume and temperature, that is regarded and referred to as humidity. So here, the air's holding capacity in different region, the amount of water vapor that air can hold up, that varies from one region to another. It is not going to be the same everywhere, right? So here, for example, if you observe, let's suppose these dark dots, they represent the water vapor. And here, obviously, you'll find that the presence of water vapor is greater in this air parcel. Now, again, as I told you, in order to understand any of these concepts, always attack from the basics. So if you take a look at the basics of it, imagine this is an air parcel. Now, here, you will have the air molecules, the gaseous molecules which are present, or rather, here you will come across the gaseous molecules which are present. Okay. Now, in between the spaces that are left, that is what the water vapor will occupy. So here, water vapor will end up occupying the space in between. Isn't it? Water vapor will occupy the space in between. Now, the total amount of water vapor that an air parcel can carry at a given temperature in a place, that is referred to as the carrying capacity of the air. So when we talk about the term carrying capacity of air, it refers to total amount of water vapor that an air parcel can carry can hold at any given temperature. What is air parcel? Air parcel is any volume of air, any sample of air that we consider, that is parcel of air. Parcel of air is not the parcel that you receive by post and the courier people, they bring you that parcel. It is not that parcel. Parcel of air refers to any given volume of air in consideration. Now, this carrying capacity overall, this carrying capacity is something which is temperature dependent. As I told you, that at any given temperature, what is the total water vapor amount that it can hold? So that is something which varies with temperature. How? Let us try to understand that. So let's suppose I heat this air parcel up. I provide heating to it. Now, when I heat it up, the same air parcel or the same volume or the same sample of air, let's suppose I heat it up. Now, what will happen to the gaseous molecules? They will become agitated. Many of them will leave the space, isn't it? So, in that same volume, now you will have lesser amount of gaseous molecules. Many of them would have escaped the system. Now, the spacing available in the volume, that spacing from the earlier scenario, you would observe that the spacing has increased. Now, in that spacing, you can accommodate many more water vapor molecules. You'll be able to accommodate significantly more amount of water vapor molecules. Okay. So here, can we not say that upon heating, the carrying capacity of the air parcel has now increased? We can say that because now there is a greater gap in which the water vapor molecules can be accommodated. So we can always come to a conclusion that carrying capacity increases or heating of the air parcel, heating of air increases the carrying capacity. We can say that, right? Now, conversely, let's suppose I cool this down. I provide cooling. Now, when I cool this down, what will happen to the air particles and the air molecules? They will lose energy. They will start sticking much closer to each other, isn't it? They will lose energy. Now, they will start sticking closer to each other. So what happens to the gap in between? The gap in between also reduces. So here, you can accommodate only a limited amount of water vapor. So as compared to earlier, can I not say that when I have cooled down the air, the carrying capacity has reduced ever so slightly? Right? Upon heating, the spacing increased, so the carrying capacity increased. Upon cooling the same air parcel down, the carrying capacity significantly reduced. So that is how sometimes humidity, the level of humidity, is also impacted by temperature. So water carrying capacity of an air parcel varies with the temperature of the air. A warmer air parcel can hold more amount of water vapor as compared to a colder air parcel. Okay, so when we heat up the air parcel or an air column, its ability to hold moisture significantly and substantially increases. When we cool the same air parcel down, its ability to hold moisture, carry moisture, significantly reduces. So that is the impact of temperature overall. Okay. Pressure has got a different impact. Okay, so pressure of parcel of air, that has got a different impact on it, but the carrying capacity is largely determined by the temperature conditions. Temperature condition is a major determinant in terms of carrying capacity. Okay, now after this, here we come to the various types of humidity. How is it that you measure what is the amount of water vapor carried in an air parcel? How is it measured? So you can measure in terms of different units and you can measure in terms of different scales in proportion. So how do we end up measuring that? That what is the amount of vapor carried? So there are certain methods. First of all, is the first method is weight of water vapor. Weight of vapor per unit volume of air. So this is types of humidity. How do you measure the amount of water vapor which is carried? So first is basically weight of vapor per unit volume of air. Then you also get another measurement, weight of vapor per kg, per kilogram of air. So in this case, you are measuring the humidity in terms of volume of air. In this, you are measuring in terms of the weight of the air particles in itself. And then you have the one which is more prominently used, and that is basically weight, or rather moisture which is present, moisture present divided by total carrying capacity. By the total carrying capacity. So that is basically another kind of measure of humidity. So you have these three different types of measures of humidity. This one is referred to as absolute humidity. This is what is referred to as specific humidity. And then this is what is referred to as relative humidity. Okay, so these are basically the three different types of measure of humidity that you will come across. So when we talk about absolute humidity, it is the total weight of moisture content per volume of air at any given temperature. So here expressed in gram per meter cube, and it decreases in general from equator to poles. Why does it generally decrease from equator to poles? This is the general observation as one moves from equator to the poles. So here you have to understand the relation between the temperature and humidity again. Here, while discussing about the temperature and humidity, we have discussed about the fact that lowering temperature, decrease in temperature, yes, very good. Decrease in temperature reduces the carrying capacity. Now, if the carrying capacity in itself is reduced, obviously, they will be carrying lesser amount, right? So in general, when you move from equator to the poles, there is a decrease in temperature which is experienced. That is where the carrying capacity will also reduce. That is when the moisture carried will also reduce. So that is why generally you will experience that it decreases from equator to the polar region. So in order to understand this, think about the scenario. Let's suppose you consider an air parcel, and the volume of this air parcel is 1 meter cube. Now, in this air parcel, let's suppose you have 5 grams of vapor, right? So the absolute humidity will be 5 by 1, right? That will be the absolute humidity, gram per meter cube. Now, this amount of vapor that it is carrying, this amount of vapor will start to reduce with temperature, and that is why absolute humidity reduces as one moves from equator to the poles because of decrease in temperature. Decrease in temperature. Then after that, we have specific humidity. What do we understand by specific? So here, as I had told you earlier, weight of vapor per kg of air. So mass of water vapor per kilogram of air. That is, what is the weight of air in terms of the air molecule. So here, for example, let us consider an air parcel in this case. Now this air parcel, let's suppose, has got a weight of 1 kg. Now, if I heat it up, it will expand, right? So let's say the volume expands. So let's suppose if I heat it up, this expands ever so slightly and it becomes slightly bigger upon heating. But still, the weight of it will still be 1 kg. So the total vapor contained in the air parcel, in 1 kg of air parcel, that is specific humidity. Now, this specific humidity basically does not change or is very rarely impacted by change in volume or temperature, because even if you change the volume, the number of particles of air will still be very similar. So what will be the unit in this case? It will not have any particular unit because both of them are units of mass and weight. They will cancel out each other. So it doesn't have a unit associated. Okay? And then the one which is more prominently used, which is very frequently used, when you read the newspapers, or if at all you read the newspapers, if at all you listen to the news headlines or the weather report in general, you will hear about the terms that the humidity is 80%, 70%, 90%. All that figure represents the relative humidity. Relative means compared to something. Whenever it is relative, be it relative velocity, relative acceleration, relative humidity, compared to something. So relative humidity means the total amount of moisture that the air has compared to the total amount of moisture that the air can hold up. That is relative humidity. So the ratio of amount of water vapor present to what it can hold. So relative humidity can also be given overall. You see, it is expressed in percentage in general. So relative humidity can be expressed as moisture present divided by carrying capacity into 100. Okay. Now this carrying capacity changes with temperature. So relative humidity can also change with temperature. How? So for example, let's consider an air parcel. Let's consider an air parcel and let's consider different situations or scenarios. Okay. Now here, let's assume that this air parcel is at 35 degrees Celsius. At 35 degrees Celsius, let's say the carrying capacity, let's say is 10 grams. And the actual vapor present, let's suppose, is 5 grams. So what will be the relative humidity in this case? What do you think? Okay. I'll give you some time to sort out your mathematics because I get very interesting answers in this case. Okay. Good. How do we get at figures like 700? 1.4, 350, 0.5, 20. This is actually fun. Looking at the answers is actually very hilarious. I just hope you could also from your end look at the various answers which are being presented in front of me. It fills me with immense amount of confidence after this. Okay. All those of us who are indulging in very complex calculations as of now, and all those of us who are okay, so relative humidity is the moisture present by the carrying capacity into 100. What is the moisture present here? 5. What is the carrying capacity? 10. Into 100 will give you how much? I will simplify it for you. This is 2. This is 50. So that will be 50%. So in this case, regardless of whatever numbers you have thrown at me, 700, 350, 1.42, 0.142, all those various numbers that you have thrown at me, understand that in this case, relative humidity is never going to be more than 100% on the ground surface. We'll come to it later. So relative humidity in this case is 50%. Anybody having doubt in this? Please ask. Okay. Good. Now here, when let's suppose I heat it up. Let's suppose I heat this up. Okay, heating is provided. And actual vapor is not changing. The vapor which is present here, let's suppose the vapor present is 5 grams. And I've heated it up to around 42 or 43 degrees Celsius, let's suppose. Now, upon rise in temperature, what happens to carrying capacity? Carrying capacity exhibits an increase with heating, with the rise in temperature. So carrying capacity will increase. Let's assume that the carrying capacity has now become 15 grams. So what will be the relative humidity in this case? Okay. This time most of you are sorted enough. So relative humidity in this case will be 5 by 15 into 100, roughly 33.33%. So let's assume relative humidity in this case is 33%. So earlier, relative humidity was 50%. Now, upon heating, observe the relative humidity. It has decreased. Why? Because the carrying capacity has increased. Carrying capacity is present in denominator. Now, let's suppose I provide cooling to it. Okay? Let's suppose I provide cooling here. Now, here, the actual vapor present is still going to be, let's suppose, 5 grams. And I have cooled it down to 25 degrees Celsius in a manner where the carrying capacity has now reduced to, let's say, 8 grams. So what will be the relative humidity in this particular case? Let's see. Good. Very good. Some of you are coming up with very unique numbers, not even in the ballpark. Okay, let me simplify the calculation here for you. In this case, the relative humidity will be 5 by 8 into 100. And that will come out to be, it is a very simple calculation, guys. It will come out to be 62.5. Okay, so roughly around 62%, let us assume. So relative humidity in this case comes out to be 62.5%, or let's assume 63 for that matter. 63%. So what do we conclude from this? We can conclude that when we heat up the air parcel, or when the air parcel gets heated up, the relative humidity reduces. When the air parcel gets cooled down, the relative humidity will exhibit a kind of an increase. So, heating the air parcel or heating of air parcel of air reduces the relative humidity. Cooling of air parcel increases the relative humidity. Okay. So heating of air reduces the humidity, cooling of air tends to significantly increase the humidity. Now, why do we care about it? If the humidity level increases or decreases, why should we care? Humidity does impact us on a daily basis. In our day-to-day lives, humidity has got a lot of impact. For example, suppose, imagine, or if the imagination is not working at this point of time in Sunday, let me give you an example. Let's suppose that you are in a coastal area like Chennai or Kolkata or Mumbai. Now there, you would experience that even if there is a very hot condition and you are perspiring a lot, there is a lot of sweat rolling down, but you will find that the sweat doesn't evaporate at the same rate. You'll feel very uncomfortable in that scenario, and you are most likely to experience dehydration. Now, if you go to Delhi or Chandigarh, even if the temperature is 40, 42, 43 degrees Celsius, but when you perspire, when you sweat, immediately it evaporates. Why? Because the air in those areas around Delhi, Chandigarh, that is dry. So the air has got the capacity to absorb more. Whereas in the coastal areas, the air doesn't have the capacity to absorb any more moisture. That is where you feel uncomfortable. That is where the moisture tends to stay for a longer time period. So that is where the humidity comes to play. Now, when you have humidity levels coming particularly down, for example, recently you would have come across the news story that in the region of Bangalore, many people were experiencing static shocks, in the sense that when they would basically touch anything, they would experience a static shock, right? While many of them attributed it to supernatural phenomena and supernatural intervention. But the reality of it was that in Bangalore, the humidity during the dry season that falls to as low as around 20 degrees Celsius. That is unhealthy for the human skin and so on. So that is where charge starts developing due to very dry conditions. So humidity does impact us. And also the level of humidity gives us an idea about whether condensation will happen or not. And if yes, when condensation will happen, what will be the conditions which will be observed. For example, if the relative humidity, let's say, reaches 100%, that means what? When the relative humidity is 100% means the air is carrying as much amount of vapor as is the carrying capacity. That much vapor the air is holding up. Any more vapor that it has, or any amount of reduction in carrying capacity, if it will happen, that excess water or water vapor will start to condense. So it gives you an idea about the rainfall, dew formation, condensation. Everything is determined by the humidity content. Humidity is also very important for the survivability of plants and animals. Majority of the plants and animals you will find they are unable to survive in very dry weather conditions. Few of them are adapted to dry conditions, but majority of them they are unable to adapt to drier conditions. So here that brings us to the next concept, that is saturation of air. So saturation of air, when we talk about, what is saturation? When you say that we have reached saturation, that means there is no capacity to take anything more, right? So when we say saturation of air, that is when the air carries, or the air has got the presence of enough amount of water vapor, or as much amount of water vapor as it can carry. So the air containing moisture to its full capacity at a given temperature is said to be saturated. It is carrying as much water vapor as it can carry. So saturated air, if we talk about saturated air, what will be the relative humidity of saturated air? Let me know. Good. Very good. So relative humidity of saturated air will come out to be 100%. It is holding as much amount of moisture as it can carry, equivalent to the carrying capacity. So that is basically the saturated air. Now here, again, let us develop some concepts in this case. Let's suppose I have an air parcel. Let's suppose this air parcel is at temperature is 35 degrees Celsius. Carrying capacity, let's suppose, is 10 grams. Holding capacity is, or the absolute amount of vapor that it is holding, let's suppose is 8 grams. Okay. Now in this case, what will be the relative humidity? It will be around 80%. Okay. Now here, let's say I cool this down significantly. And I cool this down let's suppose I cool this down to a temperature of 25 degrees Celsius. And in 10 degrees C fall of temperature, let's say the amount of moisture is same. Carrying capacity is now 8 grams. So the amount of vapor is 8 grams. Carrying capacity is also 8 grams. So in this case, the relative humidity is 100%. Isn't it? The relative humidity is going to be 100%. This is saturated air. Saturated air. Now, if I were to heat this again, if I heat it again, or I will not heat it, let's say the air gets heated up due to solar insolation and so on. Let's suppose it gets heated up. Now, when it gets heated up, what will happen to the air in terms of carrying capacity? Carrying capacity will increase. So it will again become unsaturated. It will become unsaturated. Let's say the temperature increases to 30 degrees Celsius due to heating. Carrying capacity will increase. Whatever might be the relative humidity, it will be unsaturated. Suppose I cool it down even further. I cool it down further and I cool it down to around 15 degrees Celsius. Okay, so much so that it was holding 8 grams. It is still holding 8 grams overall before the reduction in temperature. Now the carrying capacity has reduced. Let's assume the carrying capacity is reduced to 5 grams. Now carrying capacity means that is the total amount it can hold. But the air had around 8 grams. It can hold only 5 grams. So what do you have? You have a surplus of 3 grams. Of moisture. Isn't it? Now you have a surplus of 3 grams of moisture. What will happen to this surplus of 3 grams of moisture? What will be the aspect of it, or what will happen to it? It is this 3 grams which will condense. So this surplus undergoes condensation. Condensation. Now, if that saturation is reached at a temperature higher than 0 degrees Celsius, so condensation will result in liquid water droplets. If, let's say, in order to reach saturation, the temperature has to fall to -5, -6 degrees Celsius, and then it reaches saturation, the condensates will be in the form of ice particles. Generally, you will observe the ice which sits on the ground surface in very cold areas, the freezing happens. That is when the saturation is reached at temperatures lower than freezing point. So when you cool down the saturated air, upon further cooling, it leads to condensation. Okay? That is how condensation occurs. So here, if you talk about condensation, condensation can be in different forms. If that saturation has been reached at higher than 0 degrees Celsius, liquid water droplets will be formed. Now here, condensation is something that we experience in our day-to-day lives. On a day-to-day lives, we experience this condensation to be happening. How? So let's suppose you take out a bottle from the fridge, right? From the refrigerator, you take out a bottle, you keep it on the table. Now, after some time here, if you observe, let's suppose you have kept a bottle, a bigger bottle, let's suppose. Now, you have taken it out of the refrigerator and then you have kept it on the table, let's suppose. Now, in the present summer month, this is something that you can experience very easily without much difficulty. You can actually experience this. So here, as you keep the bottle outside, after a few moments, you will start observing the development or the buildup of these liquid droplets on the outside. Like this. These droplets will develop. Now, where does this droplet come from? Have you ever thought about it? That where is it that on the outside these droplets come from? Is it that the water from the inside is leaking out? No. There is condensation happening. But condensation from where? Condensation from the air surrounding it. How? So, for example, in this scenario, what actually happens is that, let's say this bottle has been in refrigerator for some time. So let's suppose the surface of the bottle is at a temperature of 2 degrees Celsius, as long as it is in the refrigerator. Now, when you keep it outside, the air parcel which is in contact with this, the air parcel will cool down, cools down, isn't it? The air parcel cools down. Now, when this air parcel cools down, it will reach saturation very quickly, reaches saturation. And beyond that, if the cooling happens, condensation is observed. Condensation will never happen in thin air. Condensation will always require a surface. Without surface, condensation will never happen. If you keep on blowing very cold air and without any surface, the same air will never condense. As long as there is a surface of contact, only then condensation will be initiated. It is this condensation which leads to the formation of dew. It is this condensation which leads to the formation of clouds also. At the ground surface, when this condensation is observed, then we observe it as dew formation. If it is observed in upper atmosphere, that is when we say it is a cloud formation. Okay? A couple of questions I will take. Nitin, so not yet understood how we come to know the carrying capacity. So that carrying capacity, basically, understand we have only referred to temperature here. It is the PV characteristic, pressure, volume, and temperature characteristic which is calculated. And accordingly, we get to know that what is the spacing, what is it that it can hold, what will be the vapor pressure. So by the laws of thermodynamics, that is determined. And Pranay, humidity in upper atmosphere and ground surface is different. Absolutely, yes. Vapor present at the upper atmosphere is very low, but in the upper atmosphere, the temperature is also very, very low. Okay? Any other doubts that you have? I hope that you are not finding any kind of hesitation in terms of asking the doubt. Never be ashamed to ask any doubt, regardless of how stupid that doubt might be. At max, what will happen? We will have some fun in between. But if that doubt gets solved, then you will never forget that concept. So please don't hesitate if you have any doubts which are present, as long as it is related to the subject. Okay, don't have a doubt related to other aspects of your life. So this is the aspect of condensation. Now after this, we come to the portion of development of dew. So this is something basically which you will observe in the coastal areas almost throughout the year. And also in the other parts of the country, you will observe this in winter nights in general. This is again a result of condensation which has happened. For example, if you follow any kind of sports, maybe football, maybe hockey, maybe cricket, you would have come across a scenario where the ground basically develops dew during the evening time, right? Or in general, if you like walking in the park in the evening or early in the morning, sometimes you will observe that the grasses, they develop these tiny water droplets. These tiny water droplets, that is what is referred to as dewdrops. Okay. Now here, when we talk about dew, tiny drops of water that form on cool surfaces at night when water vapor condenses. The dew point is the temperature that the air needs to be cooled in order to achieve a relative humidity of 100%. Now, if I ask you a basic question, and the question I will write it down so that you don't have plausible deniability. So I'll write down the question. Dew point temperature, that is the temperature which is required for the formation of dew. Temperature is always, or rather than this, let us develop the concept first and then I will throw the question at you. It will make much more sense then. So let us develop the concept first. So when we talk about dew, it is a result of the process of condensation. Now this condensation will happen only after saturation. Now that is something which varies from one area to another. What is the amount of moisture which is present? That determines how easily saturation will be attained. So here I will give you for consideration two different areas. Let's suppose we consider where recently the SCO summit was held. That is, let's consider Goa. Let's consider Delhi. Okay, Delhi, why I have considered? Generally an interior area in the inland, which is going to have very dry air condition. Now in Goa, let's suppose temperature is 35 degrees Celsius, relative humidity is 85%. Now in Delhi, temperature, let's suppose, is 42 degrees Celsius, relative humidity 65%. Now, if we consider Goa, now this is the daytime temperature. In the evening, the temperature will reduce. So let's suppose the temperature reduces to 30 degrees Celsius. Relative humidity at 30 degree, let's assume, reaches 100%. It has reached saturation. Now, if the temperature reduces even by 1 degree Celsius, if the temperature is even, let's say, 29 degrees Celsius, will we observe dew formation in this case? What do you think? Will we observe dew formation if the temperature is at 29 degrees Celsius? Yes, absolutely yes. So here, dew formation. Whereas in Delhi, if I reduce the temperature during winter months, if the temperature reduces, let's say, to 25 degrees Celsius, and that sharp reduction in temperature takes the relative humidity to 90%. Again, because it is winter, if temperature reduces to 12 degrees Celsius, relative humidity in that case reaches 100%, let's suppose. So eventually, if the temperature here even becomes 11 degrees Celsius, there will be dew formation. Isn't it? So observe that in the region of Delhi, for the dew formation, the temperature has to reduce around 10 degree, 11 degrees Celsius, sometimes even lower than that. Whereas in Goa, in Visakhapatnam, in Mumbai, in Kolkata, in Chennai, in Trivandrum, in all the coastal areas of the country, dew formation can be observed even at 29, 30 degrees Celsius. Now, how is it determined? Or what determines that at what temperature the dew is formed? It is determined by the moisture present, the humidity content. So if the humidity content is high, dew formation will always take place at a higher temperature. If the moisture content is very low, dew formation will happen at an absolute low temperature. That is why in the interior areas of the country, which are away from the coastline, for example, the northern parts of the country, dew is observed only during the winter months because the humidity content is low. Whereas when we talk about, let's say, the coastal areas of the country, every evening almost, you will observe dew formation. It develops on any kind of surface. It develops on, let's say, if you have parked your car outside or on the metal fencing or on the grasses, sometimes the soil also becomes damp. So dew formation will always take place on a surface. So if, let's say, if saturation temperature or before that, here, dew point is what? Dew point is the temperature the air needs to be cooled to in order to achieve 100%. So whenever the 100% relative humidity is reached or the air gets saturated, that is what is dew point temperature or the saturation temperature also. Now, if saturation temperature, let's say, is below freezing point, then what will happen? If the saturation temperature is below the freezing point, and that can be only in two conditions. In one condition, if the air is very, very dry. So if the air is very dry, then saturation temperature will be less than 0 degrees. And in that region, for example, Bangalore, the case I was giving you. Now, during the months of later February and early March, Bangalore was experiencing a relative humidity of 20%. So if regardless of how much you cool it down, it will never lead to dew formation. But let's suppose in an area like Jammu Kashmir, in an area like Himachal, in an area like northern parts of Punjab, during winter months, in an area like Arunachal, Uttarakhand, in Sikkim. Now, suppose in those areas, the saturation temperature is below the freezing point. Then what happens? Then you will observe that here, temperature, or rather rather than dew formation. Dew formation. What happens? What is observed? Frost develops. What is frost? I hope we have seen frost at some point of time or other in our lives. If you have not seen, you can look at the images also. Basically, imagine a scenario where sometimes the ground is covered, or these grasses that you see, they will be covered with very tiny pieces of ice, transparent ice. It is not snowfall. It is where you wake up early in the morning and you observe that even the electricity poles, etc., they are covered with very thin piece of ice, which melts as the day progresses. That ice will melt and go away. So that is where saturation temperature is very, very important, very relevant in terms of determining when and where condensation will occur and how it will occur. Now, that brings us to the associated concept of clouds and the formation of clouds. Ever since mankind gained a kind of a collective consciousness, we have always been, in a way, significantly surprised and significantly curious about the clouds. We have always looked at the clouds in a manner of surprising aspect, that how they are formed, where they are formed, why they are formed. But cloud formation also is always associated with condensation. The clouds that you see, they are basically accumulation or an accumulation of supercooled liquid water droplets and sometimes even ice particle. So clouds are defined as aggregate of innumerable tiny water droplets, ice particles, or a mixture of both. So what happens and why it happens? So always clouds will be formed, always formed as a result of rising air column. Always formed as a result of rising air column. Always. So if you don't have a rising air column, you will never have cloud formation. And now we have studied about pressure. So this indicates what kind of pressure? High pressure or low pressure? A kind of low pressure. So low pressure will be associated with cloud formation. It will never form where you have a sinking air column. Clouds will never be created. Okay. Right now it is raining in Nagpur. Is it because of low pressure? Yes. As I told you in the initiation of the class itself, as of now, across the country, two significant low pressures have developed. A very significant low pressure has developed. One is in the region of Vidarbh, that is in the eastern portion of Maharashtra around Nagpur, and the other is in the region of Bay of Bengal. So the low pressure around Vidarbh, which has developed, that is bringing rainfall, significant rainfall for the next 2 to 3 days. It will bring in the region of, or in the region of Maharashtra, in the portion of Karnataka, in the portion of Madhya Pradesh also. And the low pressure developed over the region of Bay of Bengal, that is bringing rainfall in the associated areas of Odisha, West Bengal, Jharkhand, Bihar, and even in some parts of Assam. Okay, so cloud formation is always associated with the low pressure. So here, when we talk about, let's say, the ground surface, now here the air starts rising up due to various factors, maybe due to heating, due to, let's say, evaporation, due to, let's say, dynamic factors. Air rises up. Now when the air rises up, it will cool down, it will start cooling down. Upon cooling down, eventually it might reach the level of saturation. Let's suppose it is here that air reaches saturation. it can still continue to rise up, because even after, let's say, it has reached saturation, does not mean it is colder than the surrounding. It might still be warmer than the surrounding air. So if it rises up any further, even a small height further, condensation will be observed, and all the various different water vapor particles, they will either condense into liquid droplets, or if the temperature is low enough, they can condense directly into ice particles. Now they will start accumulating. They require a surface. Without surface, no condensation. So what provides them with that surface? That surface is provided with the help of the dust particles. The dust particles, they provide that relevant surface. Very good. So around the dust particles, they start accumulating. Condensation starts happening. So around all these dust particles, condensation starts to happen. And eventually, you will observe a cloud formation. Now, this cloud which is formed has formed why? Because the air has reached saturation, and eventually, if it has risen further, means the temperature has dropped ever furthermore, and condensation has happened across the hygroscopic nuclei. Now, this cloud, it is not solid. It is not an absolute solid where you cannot pass through the clouds. You will find on a daily basis, airplanes, they cut through the clouds, they move through the clouds very easily. So these are composed of those dust particles. Around them, you have the development of ice which takes place, or liquid droplets which are present. Now, all of these small particles, they are so small and light enough that they can be suspended in the air itself. They are very, very light. But slowly and steadily, as more condensation happens, the particles, they start becoming larger. Eventually, you'll find that the ice particles which are present, which become larger and larger and heavier, these ice particles, they start to fall. Now, as these ice particles are falling, will it be correct to say that they are coming to a region of lower temperature, or will it be correct to say that they are coming to a region of higher temperature? As the ice particles are falling from the clouds, what will be the correct option in this case? They are coming from lower temperature to higher temperature, or higher temperature to lower temperature? Very good. It is coming from lower temperature to higher temperature. So as it is coming from lower temperature to higher temperature, it will experience melting, right? Because near the ground surface, you have higher temperature. It will experience melting. It will get converted into droplets, liquid droplets. And those liquid droplets you experience in the form of rainfall. Okay? Liquid droplets. Ice melts into droplets due to higher temperature near the ground surface. Near ground. Because I hope this portion is clear that when we talk about the air in the region of troposphere, it always will experience a positive lapse rate. Positive lapse rate. Now, positive lapse rate in the sense that temperature will be higher in this case. And as you go higher up, you will experience lower temperature. Isn't it? So when the ice particles are falling, They are falling from a region of lower temperature to higher temperature. That is why the ice particles will start to melt, right? But then why do we experience snowfall sometimes? Sometimes we experience snowfall. In India, where do we experience snowfall? Regardless of whatever the social media news channels tell you, in India, we experience snowfall only in certain restricted regions. We experience snowfall in high altitude mountainous areas, or in the region otherwise, if you talk about the state or the region distribution, Ladakh, Jammu Kashmir, Himachal Pradesh, Uttarakhand, Sikkim, and Arunachal Pradesh. Only in these areas we experience snowfall. So there, what happens? Why do we experience snowfall? That is because in conditions when the temperature of the ground is very, very low, let's suppose temperature at ground surface if is very low or around freezing point, then what will happen? In that case, these liquid droplets that you saw, these liquid droplets which were falling, they would be impacted by that low temperature and they would refreeze into smaller snow particles. And these snow particles will then fall down on the surface. And that is what we refer to as snowfall. So that is how you observe the snowfall. So in this case, liquid droplets refreeze into snow. Okay, that is why you experience this kind of snowfall. Okay, so that is why you experience snowfall in certain areas where the ground temperature is very, very low. So all precipitation in cloud region will be once ice in majority of the cases, Santosh, yes. Higher up, majority of them are ice. Okay. Which portion you want me to repeat, Vivek? Kindly let me know. And Shreya, how is a very vague question. How what? How cloud formation, how air reaches saturation, how rainfall, or how snowfall? This entire slide you want me to repeat? Okay. Cloud formation takes place as a result of condensation, and that condensation happens if you have a rising air parcel. Only in that case you have condensation which happens. So when the air rises up, in that situation, as the air rises up, its temperature will slow down, its temperature will actually fall, its temperature will drop. Why? Because of the expansion of air, the adiabatic expansion. So the air temperature falls down up till the air reaches saturation. If the air rises any further, all the water vapor which is present there, it will start condensing. It will start condensing around various particles, and that is where you have the cloud formation which is taking place. And that cloud formation is an aggregate of water vapor, ice particles, etc. Now, eventually, when the cloud is formed, now these particles are very, very small. They can be held up in the air by the movement of the air particles itself, or because they are so light, they can be held up in the air. But eventually, as more and more condensation will happen, these ice particles become so very large that they are aided by gravitational pull, because they become heavy enough and they start falling. When they fall, eventually after a point of time, due to higher temperature that is experienced closer to the ground surface, these ice particles will melt and they will get converted into liquid water droplets, and that is how we get rainfall. In case or in situation where the ground temperature is very low, below freezing point or around freezing point, that is when these particles will then refreeze, or these liquid droplets will refreeze as snow, and that is where you experience snowfall as a result of it. So that is about the cloud formation and the associated rainfall and snowfall which occurs. Okay. So now we come to the portion of thunder and lightning. Why do we experience that? Before we take a break, and we take a break, the snack break for half an hour. So we get back again at around 5:40, I guess. So take a half an hour break. At 5:40 we return, and then we will continue.